हेलो स्टूडेंट्स, वेलकम टू नीट विद वसी अंजुम यूट्यूब चैनल। आज आपके सामने मैं रिव्यू करने जा रहा हूँ ये कार्डियोवैस्कुलर की बुक, जिनके राइटर हैं रॉबर्ट एम बर्न एंड मैथ्यू एन लिवाई। सो ये बुक है कार्डियोवैस्कुलर फिजियोलॉजी की, और राइटर जो है, ऑथर, यह है रॉबर्ट एम बर्न, एमडी, डीएससी, प्रोफेसर ऑफ फिजियोलॉजी एमेरिटस, डिपार्टमेंट ऑफ फिजियोलॉजी, यूनिवर्सिटी ऑफ वर्जीनिया स्कूल ऑफ मेडिसिन, Charlottesville, Virginia. And the second author is Matthew N. Levi, MD, Senior Scientist, Ramel Camp Center, Professor Emeritus of Physiology and Biomedical Engineering, Case Western Reserve University, Cleveland, Ohio. So these are the authors of this book, and things start with this preface, and the contents of this book are as follows. The first starts with this circuitry and then electrical activity of heart. So it is dealt in a very detailed manner. This electrical activity of heart mostly dealt with this topic. This book is mostly dealt with this topic. You can see here cardiac action potentials consist of several phases. So these are the phases, and conduction in the cardiac fibers depends on logical circuit currents. Then cardiac excitability depends on the activation and inactivation of a specific currents. And the heart generates its own pacemaking activity. So these are the basic things which are dealt with. An impulse can travel around a re-entry loop, and after depolarizations led to triggered activity. Electrocardiography displays the spread of cardiac excitations. So a scalar kind of electrocardiography, and dysrhythmias occur frequently and constitute important clinical problems. So the clinical diagnosis, etc., dealt with altered sinoatrial rhythms, atrioventricular transmission blocks, premature depolarizations, ectopic tachycardia, and fibrillations. So these things are introduced. Now the second part is cardiac pump, and here the gross and microscopic structures of heart. So anatomy is discussed here. So frequently designed for optimal functions. So myocardial cell force of cardiac contraction is largely determined by the resting length of the myocardial fibers. So fiber length, etc., discussed. Excitation, contraction, coupling is mediated mainly by calcium. So ion channels are also discussed. Preload and afterload, which are very important things. And cardiac chambers consist of atria, 2 ventricle, and 4 valves. So valves, etc. Anatomy is discussed here. The sequence, contraction and relaxation of the atria of ventricles constitute the cardiac cycle. So cardiac cycles are introduced: ventricular, systole, and diastole, etc. The Fick principle is used to determine cardiac output. So cardiac output technique is discussed here in the indicator dilution technique to measure the cardiac output or flow rate. So now at the end of the every topic, it's summarized, and some questions are based upon this topics are also discussed and explained with answer. So regulations of the heartbeat. Heart rate is controlled mainly by autonomic nervous system, and here myocardial performance is regulated by intrinsic mechanisms. So the heart rate of contractile force, etc., myocardial contractility. So based upon that, the concept of heart failure is also based upon the myocardial contractility. So myocardial performance is regulated by nervous and humoral factors. And then hemodynamics. Hemodynamics is also important. So far you talk about the heart failure, etc. The research is where the parameters are hemodynamic in heart failure, research, you take the hemodynamic parameters as for the study. So these are the things here uh, studied. So velocity of blood stream depends on the blood flow and vascular areas. Blood flow depends on the pressure gradient. Relationship between pressure and flow depends on the characteristics of the conduits. Resistance to flow. So resistance is also discussed, and the flow type, laminar or turbulent, shear stress, rheological properties. So these are the things which affects the cardiac activity. And arterial, these are the physics of physiology. Arterial system, here also the physics is this hydraulic filter, arterial elasticity. So these are the things. And the pressure curves changes in the arteries and different distances of the from the heart. Blood pressure is measured by the sphygmomanometer. So the basic things here. And endothelium, which is very important nowadays, the research is based upon the endothelial activity, NO mediated regulations, nitric oxide. So these are the things here. Endothelium plays passive role in transcapillary exchange. And then the lymphatics, return of the fluid, lymphatic systems are here talked about, and the peripheral circulation and its control. So the peripheral system of transportation, that means peripheral blood flow is also a very important factor. Many of the diseases nowadays are prevalent based upon the vascular system, peripheral vascular system, peripheral neuropathy, etc. are also based upon the things. So here you can see the intrinsic local control of the peripheral blood flow. Extrinsic control of the peripheral blood flow is mediated mainly by the sympathetic nervous system, and parasympathetic, sympathetic, and epinephrine mediated. These are the things. And balance between extrinsic and intrinsic factors in regulations of peripheral blood flow. Control of the cardiac output now, coupling of the heart and blood vessels. The vascular functions curve relates the central venous pressure and cardiac output and venous return. Heart rate and vasculature are coupled functionally. Right ventricular regulates not only the pulmonary blood, so now the respiratory system, breathing system is also correlated with, and then the ancillary factors effect of venous system and cardiac output. So cardiac output is maximally discussed. Coronary circulations, now the important thing. Cardiac oxygen consumption is a function of the work performed by the heart. Coronary blood flow is regulated by the physical, neural, and metabolic factors. Functional anatomy of coronary vessels, cardiac efficiency, and coronary collateral vessels. Collateral vessels is also discussed, and special circulations. Special circulations like cutaneous circulations, skin, and the portal systems, etc. are also discussed here, like volume flow, blood flow, skin, and the amount. And regulations of skeletal muscle circulation is achieved by neural and local factors. The cerebral circulations, pulmonary and systemic circulations, renal circulations, and splanchnic circulations, gastrointestinal tract, liver, spleen, pancreas, fetal circulations, moreover. So these are the things which are studied well in this book. Hemorrhage, now the last thing, and the positive negative feedback mechanisms of interact, and some of the appendices, case study answers, whatever. These are the things here in this book. You can see this circuitry, chapter this circulation, endocrine and nervous system, and pulmonary and systemic circulations. Now the things are here. You can see pressure drop across the vascular systems in the hamster cheek pouch. So you can see here its mean pressures and here is these are the large arteries, the small arteries, arterioles, capillaries, venules, veins, and these are what? These are the inside diameter. So inside diameter and the pressure variables, and you can see here also this table and total cross sectional area, and these are the aorta, arteries, arterioles, capillaries, venules, etc., pulmonary arteries, etc., and heart, atria, and ventricles. So here the tabulated things are the cross sectional areas and blood, total blood volume. And electrical activity now starts. You can see this the ventricular action potential, ERP, RRP. ERP is what? ERP is effective refractory period, and here it is RRP, that is relative refractory period, and this is what sinoatrial. These are the B part, sinoatrial, I suppose. These are the B part. You can see cardiac fiber in the isolated cardiac tissue immersed in electrolyte solutions. So cardiac fiber activity, electrical activity, the ventricular activity, cardiac activity, electrical activity. So you can see here in millivolts, and here it is time. So you can also see here this very rare kind of graph is two things are given in the same graph. So one is this muscle twitch, and correlated with this action potentials, ventricular action potentials correlated with muscle twitch, and then these are some of the mathematical derivations, and you can see here this is what the gating of the sodium channels in cardiac cells membranes. So sodium channels activities, and then these are the first, it's very important, 0, 1, 2, 3, 4. These are the ventricular action potentials, the different phases, and discussed very well, like sodium entry, potassium exit, or calcium entry, or potassium exit, and maintenance of resting potential through potassium exit. So these are the things you can see very well explained and depicted. Then the drug effects, diltiazem for example, calcium channel blocking drugs. So the effect on the action potentials, typical action potentials in millivolts recorded from cells in the ventricle. So A is ventricle and B is SN node, this is SN node. See the difference, and atrium is the atrium. This is ventricle, atrium, and SN node. See the difference of electrical activity. And here you can see the polarized zone and depolarized zone, how the lateral flow of current results into the passage of information along the myocyte. Role of local currents in the propagation of wave of the excitation along down a cardiac fiber. And then some of the boxes are also here. Good boxes, good explanations, some extra knowledges, and some important